Are you trying to unlock the secrets of AI, machine learning, and data engineering? You are in the right place. Hi, I am Prashanto, a data engineer with several years of experience in cutting edge AI, machine learning, and data engineering projects. You are watching my channel Bytes of AI, and in this channel, I'll try to break down the complex concepts of AI and machine learning. I will show you the Pythonic way of implementation and deployment. I'll also try to explore the powerful tools behind modern data engineering. Whether you are just starting your AI journey or trying to level up, you will find practical tutorials and explanations here. If this sounds interesting or useful, please hit the subscribe button and turn on notifications. Let's explore AI, machine learning, and data engineering journey together in this new year. Hello again, welcome to the first session, and in this session I'll cover the retrieval augmentation and generation and its importance, and embedding models and vector databases. I'll assume that you guys have some bit of understanding about the large language models, the brain behind the popular product like OpenAI's ChatGPT and Google's Gemini. So first is why retrieval augmentation and generation architecture came into the picture. So it generally overcomes three problems with large language models. I'll not say uh, a problem in a sense like large language model do not have problem, but if you want to build some application with large language model, then you will face this problem. So it basically solves those three problems, main problems, which is one of them is cutoff date. So large language models, when it gets released to a market, it gets released after a fair bit of training, and once it gets released, it doesn't get that training again. So it's just released and it's being consumed. So let me give you an example. Let's say that it got trained on publicly available data like Wikipedia's, and it got released to the market on June 2024, and then some of the Wikipedia data got updated, let's say on August 2024, and if you ask LLM questions related to the latest update, it will not give you the latest update because it got updated. It got last trained on June 2024. So all it will give a backdated answer, which will not solve the purpose. So that is one of the problem with the LLM. So in general, it makes LLM static in nature. So second is hallucination. So hallucination is a kind of a problem when LLMs do not have any answer, then it kinds of wander around its libraries and it gives any random answer to your to user's response. So in this context, why I am mentioning this, because as I mentioned that LLMs generally get trained on the publicly available data, so it doesn't have access to the privately occupied data like organizations data, private organizations data. So if you ask any questions around that, it will just kind of wander around and it will give you any random answer which will not make any sense. So that's another issue. And third is the cost is because sometimes we think that okay, we do not have sometimes we acknowledge the fact that it has a cutoff date and it will hallucinate because it didn't get trained upon the private data. So why don't we kind of fine tune the large language model with my own data so that whatever response it gives, it will have an updated answer. It doesn't bother about the cutoff date because it is getting fine tuned, and it doesn't bother about the hallucination as well because it now knows my data when I fine tune. Problem with that, the architecture which you have to actually build that will be costly, because you have to include so many factors, like you have to have you need to have components like high RAM, GPU. Mainly you have to probably occupy buy a fair number of GPUs, and those all will involve cost. You have to train that model for fine tune that model for a very uh, uh, long hour, and that will also incur a lot of cost. So do you want that investment? Will that give a return on investment? Those kind of questions comes into picture. So that is also one of the major factor. And to overcome these kind of problems in building application based on LLM, that RAG pipeline came into picture. So before I go into the details of the RAG architecture, I will cover two important components of this architecture. One of them is embedding model, and another is vector databases. So what are embedding models? You can think of embedding models a kind of converter. What it does, so it takes unstructured data as an input. When I say unstructured data, it may means like word, text, an image file, audio file, video file, etc. And it converts those unstructured data to some numeric representation, which is actually, you can think of, or not think of, which is originally multidimensional vectors. So you get some structured to unstructured data. And while converting, these embedding models also try to capture the semantic context and semantic relations between those data, those files. So it doesn't lose any context, so that while answering, it will also search around the context and it will give the relevant answers. So that's the beauty of embedding models. These are basically machine learning models. So I'll try to explain with a very simple example, popular example. Let's see that. So this is a two-dimensional vector. You can see here. So that has a x values and y values, and you can see that for queen the x value is 0.3, and again for woman the x value is 0.3. These are same. And again, if you consider queen and king, you can see that y values are closer, like 0.9 and 0.7. And if you consider woman and man, the y values are again similar, closer, 0.4 and 0.2. So it kinds of looks like that they are close in certain context. uh, you can see that distance between these red lines kind of says that the vector distance between, or vector similarity between, queen and king and woman and man. Now let's give an example here. So the above equation, if you see here, you can see that queen minus woman. So if you take woman out of queen and then add man to that, then that will bring you king. How does it happen? Let's see the uh, process here. So the queen minus woman, that x values become 0 and y values become 0.5. Then if you add man to that, so you are adding 0.5 to 0.0, which gives you 0.5, and you are adding 0.2 to 0.5, which gives you 0.7. So 0.5, 0.7 is actually king. So this gives you a little bit of simplified example, like how vectors tries to actually capture the context around, and it is also relevant in a sense. So this is basically the importance of embedding models, where you are not storing the original unstructured form of data, rather you are converting it to multidimensional vectors, and then you are storing. So you need somewhere to store this converted data, right? Means multidimensional vectors, and that's when vector databases come into picture. So by definitions, vector databases are definitely different from the usual relational databases which we are aware about, and also the non it is not NoSQL databases. So it is sophisticated databases which are very much optimized to store multidimensional vectors, and also very much efficient in retrieving those multidimensional vectors from those databases. And architecture wise, it has majorly two important components. One is the storage engine, and then the indexing mechanisms. So storage mechanism, by definition, it kind of tries to optimize the storage of the databases, also tries to help efficiently retrieve the multidimensional vectors whenever required. And indexing mechanism, if you are aware about the relational databases, so indexing mechanism actually helps to organize the data within the databases so that whenever required, uh, it can be retrieved very fast. And next is that role in AI system. So it plays a very huge role in AI system, which I will come in a minute. So how does it help? Because I mentioned that it generally follows a very highly sophisticated indexing mechanism like HNSW or inverted file IVF, and which helps to retrieve any data, any multidimensional vectors very fast from the vector databases. And type of vector databases implementation, if you see in the market, you will generally find two different type of implementation. One is kind of pure vector databases. Those do not have kind of any extension. Those are only built to store multidimensional vectors. Those are like ChromaDB, Pinecone, kind of that. And also you will get certain vector databases which is kind of an extension to relational databases or NoSQL databases. For an example, if you consider PostgreSQL, there is a very well-known relational databases, but that has a extension that is called PG vector, that is actually yeah, you can say that that is integrated with the relational databases. So it's two type of implementation. One is uh, pure databases, pure vector databases, and then another is that integrated vector databases. And lastly, these are some example of vector databases like Pinecone, Milvus, ChromaDB, Weaviate. So among these four, Pinecone is managed one, and you have to pay for that if you want to use the API from Pinecone. But Milvus, ChromaDB, and Weaviate are free, open source, so you can use that too without paying anything. And now I'll go to the architecture of retrieval augmentation and generation. So in RAG architecture, the first thing is that we do about documents, right? We need some updated documents to feed the LLM so that LLM gets updated to overcome kind of the issues which we discussed earlier, cutoff date and hallucination. So we have to provide, we have to have a pipeline which kind of feed continuously to LLM. So let's say that if these are the updated documents every day or every week or every month, and that has a pipeline which continuously feed to a document set, and which finally goes through embedding model. So let's say your application have an embedding model here, and that embedding model keeps on converting. Whenever it gets some new data, it keeps on converting that into multidimensional vectors and stores into vector databases. So that's the first part of your RAG architecture. You have a pipeline which continuously update the documents and updates vector databases with the help of embedding models. And next is the data retrieval augmentation and generation. So what we generally do, we ask large language models to answer some of the questions, right? And there was a problem which we found that it probably, if it uh, uh, didn't see the data during training, it will hallucinate around the response related to a query regarding the unknown data. And also, it will not be able to provide the updated information because it has certain cutoff date. So that cutoff date and hallucination actually, uh, those two issues get resolved by continuously feeding the data here and continuously updating the vector databases here, so that overcomes the cutoff data and hallucination related issue. Now you have built an application which will uh, uh, basically access the vector database, and which will have kind of the latest information from the vector database. So that is this application. This user has opened that application, and which can actually query your vector database. And what happens next? So in uh, this area, you can see that user first query the vector database, and vector database with some questions, and vector database returns some data. You can configure that how many chunks of data need to be retrieved. So let's say that there are kind of, you have configured that whenever a user query the vector database, it will return with 10 relevant context or relevant or closest data around that user query. So this is where actually these things happen. It retrieves that maybe 10 or 20 accordingly, whatever you have configured. And then this augmented query come into picture. So what does that mean? So that is very important, because in a general term, when we query a LLM model, what happens, like LLM model just fed with our own questions, right? Like a single line question or some prompt regarding to that, that will just get fed into LLM, and LLM will parse that, and then LLM will inquire its own database and then try to find out some similar answers or some relevant answers, and then responds that back. And if it hasn't seen our data, then it will just respond some random answers to our questions or our query. But here what happens, we are this is augmented query, so this is just not simple query, but it has query along with the retrieved documents, right? Retrieved chunks. So that's why we are calling that as a augmented query here. So query along with the context. Context here is that the closest match of the original user query. So I have queried some questions related to my data here, and it has responded back, let's say, 10 relevant chunks of data against my query, and those are becoming context to my query, and that goes to the LLM. So that's the difference. So earlier LLM used to get just query and used to wander around and used to give some random answers, but this time LLM is getting some context along with the query. That's why we are calling that augmented query. And once LLM receives that augmented query, it does the magic. You know that LLM is very good with text or answering relevant questions when it has already seen the data. So that happens, the magic happens here, and it finally responds back to the user. There is a parameter called temperature. So if you set the temperature to 0, it will provide you very deterministic answers. But if you just keep on increasing the parameter value of the temperature parameter, you will keep getting some creative answers or random answers. So if we are building some application very specific to some use cases specific to organizations, so I would recommend to set that temperature value as 0 so that you get relevant deterministic answers. This brings an end to the first session, and thank you for watching. Just to recap, we learned about RAG pipeline, embedding models, and vector databases. In the next session, I am going to cover how to build a RAG pipeline using Python. If you like the content, please like, comment, and subscribe to support the channel. And don't forget to leave your comments regarding the future topics. Thank you again.